circular measure, placed a few simple questions just for a start. So we start with our formulas. There in the corner, I do have like a refresher memory, and we have the formula for this arc length. And in our deco here, the red part is your arc length that is obtained by the angle theta here, the radius r. So if you want to know that this is your chord, and if you want to know the length of that chord, you use the formula r theta, which you can see here. So I just want to give like a few seconds for you to do A. Is the perimeter. What is the perimeter of this shape here that you can see? It's a slice of a circle. So what is the perimeter of this shape? I'll give you a few minutes to do that. Don't just watch. Take a pen and a paper and actually do this. You will benefit much more if you are going to take this like a lesson where you can actually try the questions before I can discuss. I want to see something interesting. So I'm sure for most of you, this is a very simple question. So what did you do to get your perimeter? I want to believe that you you obviously knew that you have to use this formula somewhere. Otherwise, why is it there? Yeah. Otherwise, you wonder why is the formula there. So the first thing that we do here is to do this. So our theta for the given in radians, not in degrees. So take note. 1/2 radians, and if you multiply these two, what do you get? So okay, I'm going to do 12 by 6. What do you get? 7.2. So this is 7.2 centimeters. But is this our perimeter or it's our arc length? So 7.2 is this section. But of course, it's of our sector, is it? The perimeter is the, if you walk around the shape, so it covers also this length. So the perimeter, I'll just call it P, would be 6 plus 6, which gives you 12, plus 7,2. So I'll write 12 centimeters for the radius sections, plus 7,2 centimeters. What do you get? Equal to 19.2 centimeters. So I'll leave you to do B and C. Okay, let's move on to the next section. So this section, we're now looking at the area of the sector, and the formula for the area of the sector is half r squared theta. So for the derivation of this, if you want the derivation, then we can do another video for that. So in this portion of, and we are asked to find the area of sector A or B. So we want which region. I'm going to just color it. I don't know whether that okay, I'll color and then do the coloring later. So we are looking for the area, this whole thing there that I've colored in red, and the formula says you say half, so we can continue here. It's half. What is the radius of our circle? 6. We square it, and what is the angle? Times 1.2. What do we get? So we have half of 3618 times 1.2. I don't have a calculator right in front of me, so whatever you get here. So okay, we can actually do it. Is it, say, 18 by 10? It's 180. And by 2, 18 by 10, 180 by 236. 180 plus 36 is what? 216, so it's 21,6. 21,6 centimeters squared. Okay, I don't have a calculator yet. I hope it's correct. Then we look at the area of this triangle inside here. This triangle. You can use the sine rule to have AB sine C. And then usually we just do half r squared sine C. It translates actually to half r squared in the sine of the angle. What is that? So it's half of 36, which is the same as what we had the 18 times the, here I need a calculator. So I don't know if I'm right in front of me. Percent of 1.2 radians. You must remember to change your calculator into radians. If you do degrees, you get a wrong answer. Because 1.2 radians is, I believe, maybe most like 60 degrees, since 1 radian is around 57 point something radians. And then if you want to find the area of the shaded region, so is this segment here right on top here, you would need to subtract this area minus this area that you get here. So you need to subtract the total area of the sector minus the triangle, you get the top sector, and I'll leave you to do that.